Hello. In this video, we want to let y equal e to the x squared plus 1 times the square root of 5x plus 2. Okay, this is going to be a fun one. And the reason that this is going to be a fun one is because we're going to have to do several different things here. First of all, notice that there are two different functions being multiplied together here. There is an e to the x squared plus 1, and there is a square root of 5x plus 2. Now, we can treat this like we would treat any exponential, and this radical we need to treat like we have the chain rule here, because we do. Now I'm going to go ahead and rewrite all of this. This is going to give me y is equal to e to the x squared plus 1, and then times, and instead of the square root, I'm going to write it like this: 5x plus 2 all to the half power. So remember, when you have when you have a radical, a square root, it's a half exponent. Now, this allows me to go ahead and find dy dx. And because this is two functions being multiplied together, I need to use the product rule. So to do that, let's go ahead and remind ourselves what the product rule is. And it's the following. So if you have two different functions, u times v, that means that y prime is the first times the derivative of the second, plus the second times the derivative of the first. And now let's see how this would work. I'm just going to rewrite the first one, so e to the x squared plus 1, and then multiply by the derivative of the second. And the second is 5x plus 2 to the minus half power. Well, sorry. It is minus half power. Remember, we have to bring the half down in front, make that 1/2. And then 5x plus 2 to the minus half, and then times the derivative of the inside there. So basically what's happening here is we need to first use this as the chain rule. So this is u to the half power. Bring the half down in front, u to the negative half, times the derivative of the inside, which is the derivative of u. So 5x plus 2 here, the derivative of that is 5. Good deal. Now, plus the second, just rewrite it, 5x plus 2 to the positive a half power, times the derivative of the first, which is e to the x squared plus 1, and the derivative of that would be, well, first of all, the base is e, so I don't need that scaling factor of natural log. So I just rewrite it, e to the x squared plus 1 times the derivative of the exponent. Using the power rule here, bring the 2 down in front, 2 times x, and then I don't really have a plus 1 there. Well, the derivative of plus 1 is 0. Good. And this is the derivative, but we need to simplify this. Now, often when we're doing this, we're going to have common factors. Notice that there are two different terms here. There's a term here, and there's a term here. So, let's look for common factors. And first of all, notice that there's an e to the x squared plus 1 in both of these. So e to the x squared plus 1 will come out front. But also, there will be a 5x plus 2 to some power in common with both of these. Now, notice that I really shouldn't highlight all of this because that's not what's in common. It's the base that's in common. Now, normally when we're factoring out stuff that has a positive exponent. But here, we just want to look at the smallest exponent. And the smallest exponent between these two is 5x plus 2 to the negative a half power. So multiply this by 5x plus 2 to the negative a half power. Good. And then notice that the half and 5, and then just 2x, and there's really nothing else that's in common. So I'm going to multiply by what's left over. Well, first of all, notice in the first term, e to the x squared plus 1, 5x plus 2 to the minus a half, both of those are already out here, so they go away. All of that goes away. All of that goes away. But notice we have a 1/2 times 5 left over, and so that's going to leave us with 5/2 within there. Good. Now plus, because there's a plus right here. Now over here, this 5x plus 2 does exist here, but notice that the exponents are different. So whenever we're just dividing here, right? So if I take that 5x plus 2 to the half power and divide by the common factor of 5x plus 2 to the minus half power, notice what's going to happen. First of all, the base stays the same, and then we subtract the exponents. 1/2 minus the negative 1/2. But minus the negative is, of course, plus, so it's just a half plus a half, which is 1. So this is actually just 5x plus 2. So this is going to leave me with 5x plus 2, and then times, now notice what's left over other than that is just the 2x there. Good. Now distribute. And then let's go from there. Notice that we have e to the x squared plus 1, and then times 5x plus 2 to the minus a half power, and then times what's in the parentheses here. Well, first of all, we have the 5 halves, and then distributing the 2x, that gives us plus 10x squared plus 4x. Good. And then just, write that in descending order. We have e to the x squared plus 1 times 5x plus 2 to the minus a half power. And then putting that in descending order, we have 10x squared plus 4x plus 5 halves. Good. But here's the thing. There are some things we could do here. We don't generally like having a negative as an exponent, so what I'm going to go ahead and do is I'm going to move that from the numerator that you see into a denominator. So that's going to give me e to the x squared plus 1, and then times what's left over was this 10x squared plus 4x plus 5 halves. That's everything in the numerator, but in the denominator, that term that has that negative exponent goes down there as a positive exponent, making that 5x plus 2 to the half power. Notice it's a positive exponent because I moved it from a numerator to the denominator. Excellent. And now I need to multiply both. Well, okay, technically I'm done, but I don't like having a 5 halves like that. And so what I see is that there's a common denominator of just 2 right there. So I'm going to multiply both the numerator and denominator by 2. And then I'm going to distribute this 2. You can only distribute the 2 once, and I'm going to distribute into the fraction there. And so that's going to give me the following. In the numerator, we have e to the x squared plus 1. And then distributing that 2, that gives us 20x squared plus 8x plus 5, because 5 halves times 2 is just 5. And then all over, and we still have the 2, parentheses 5x plus 2 to the half power. And there you go. That is dy dx. Awesome. Well, that was fun. Alrighty. Well, I think I'm going to go ahead and end the video here, and I will see you in the next one. Have fun.